Okay, I think, okay. So now, welcome everyone to Cloud Data Driven Online User Group Meeting. Who am I? I am Jean-Joseph. I'm currently working as a data engineer. I've been in IT for over 18 years. I am currently located in New Jersey and originally from Haiti. I'm your host for today. We do have rules. You guys are free to comment. However, do it with respect. There must be no offensive comments. I have your microphone turned off. However, at the end of the session, I will unmute everyone to, in case if you have any question, you will be able to ask. Or if Thomas requests me to unmute everyone to ask question while he's presenting, I'll be happy to do that. And then if you guys do have a question while you are on mute, while you are muted, I would suggest you to raise your hand and I will unmute yourself. Feel free to follow us on social media. We do have our hash, which is Cloud Data Driven, to keep up to date, okay? And then join our social media. We are on LinkedIn, Facebook, Eventbrite, YouTube, Meetup, and Twitter. Follow us. Okay, our agenda for 2 days is optimizing SQL Server for large table scan. You already know the speaker. The speaker is Thomas. Thomas is an IT professional with over 35 years of experience in programming, designing, and also he wrote books and he contributed to some of the books as well, being written by other people. He's a speaker. He's a Microsoft MVP. He's gonna tell you more about himself. We do have some other sessions lined up. We have a tons of them, but I just want you to know the next one. Chris from Microsoft will present Azure SQL Server Managed Instance, right? And then Paul Andrew will present creating a metadata-driven processing framework using Azure integration pipeline. And I'm pretty sure you guys don't want to miss these two sessions as well. And there are tons of other sessions up there. Feel free to visit our meetup group and also save your spot. If you guys do have any session you want to present, feel free to email me at jean.joseph@bigdatadriven.org. Thomas, thank you so much for being here and thank you for your presentation. It is an honor to have you here. Feel free to share your screen and start with your presentation. Introduce yourself as well. Thank you. Hello, Tom. Are you there, Tom? Thomas, are you there? Sorry, guys. Tom lost internet. It seems like he's about to reconnect again. Just bear with us. You are back, Tom?
I hope so.
Can you hear me?
I can hear you. Can you hear me?
Perfect. You can start.
Yeah. In a second. So, hello. Sorry, my internet decided it's time for a break. I hope you can hear me. So today we're going to talk about how to optimize SQL Server and its databases for large fact tables. So let's get started. So my name is Thomas Grohser. I'm with SQL Server for many, many years. It's 26 or 27 years now. I did the first thing in 1994 with SQL Server 4.2. I spent the majority of my days building infrastructure and optimizing infrastructure for SQL Server just to make it go faster, more secure, more available. Helped writing a couple of books and spent a lot of time with Microsoft and the product team to give them feedback on what I discovered in my large installations that now 10 years, 15 years later are absolutely mainstream. Yeah? So good. Let's start with the actual talk of the day. You will get all the slides at the end. I will give them to the organizers so we can share them between the group. Yes, yeah. So first I'll define the issue, the problem, what happens when you try to not do anything and you try to read large amounts of data. Then we have a look at which tools we have and what we can do. And then at the end, I will show you two even more amazing tools than the regular ones. And then we can do as many questions. I mean, if there's pressing question, you can interrupt me, but usually a lot of the questions that I get will be answered a little bit later in the talk. So especially in the virtual world, let's keep the questions for the end. Yeah. And there might always be important stuff popping up on the slides at any time. So what is a large fact table? So what is a large table? And that is a question that there is no answer to because it really depends. First, it's a moving table and it's very individual to the person who asked the question. Yeah? So I can give you a couple of answers. In 2001, so 20 years ago, for me, and I'm talking for me, big was more than 1 billion rows and more than 90 gigabytes of data. Yeah. Today's, you can handle that with an iPhone. But back in 2001, that was pretty much high-end, largest server you could buy at the time. And and we generated that amount of data once a month. It was a billing solution for an internet service provider, and all the individual packet transfers were summarized into the bills, and that what was happening. So 2001 was 1 billion rows and 90 gigabytes. Today, I would not consider either one of these measurements as big. In 2011, so 10 years later, for me, big was 1.3 trillion rows. So more than 1,000 times more than 10 years earlier, but only 250 terabytes. So the number of rows didn't increase as much as the overall size of the data. So that database then had 1.3 trillion rows, 250 terabytes, and was using log shipping to have one copy somewhere in Europe and the other copy somewhere in Canada. The table contained every poker hand ever played on a website. So yeah, 2011, I considered that big. Yeah. Could we handle it? No problem. But compared to what else was out there, this thing was big. Now it's 2021. What's big for me? A good question. I don't know. Sorry. I can tell you it was about 10 petabytes in 2019 in a single table. Yep. So 2021, I work for a company, I cannot tell what, but 10 petabytes doesn't scare me anymore, and you can go bigger in 2021. So that's where we are now. Thing is, I'm 100% sure big means something different for most of the audience. Yeah? But that's what I said, it's dependent. If I would not be me in my environment, everything above 50 billion rows, I would consider very big in databases. Yeah? And once you start having databases larger than 10 terabytes, you have to do something. If you don't do something special, you will be in trouble over time. SQL can grow massively, but you have to do something about it to help SQL Server grow in a reasonable way. If you just do nothing, you will be in trouble eventually. So let's refer to my favorite teacher, size matters not, except when you watch a movie in a theater. Having the right tools and the knowledge, what you need to do with data to help SQL Server to process it as fast as it can is the key to this problem. So let's look at one problem, and that's the problem we're gonna solve during this talk. Yeah. So, and that's a common thing. There are 30 different reports on a big fact table in a database, and each one of them needs to scan the whole fact table. Right? And that's not uncommon. That's like one report by customer, the next one by region, the next one by product, the next one by sales representative, the next one by commission, many things. So it's not uncommon in a company to have 30 reports that use the same big fact table, join it in a slightly different way, but basically have to read it once to get to the final data. And we had that case. We had about 30 reports, and they had to be run daily, and they had to be the data was ready at 5 a.m. in the morning, and the reports needed to be ready by 9 a.m. Yeah? So not much time, basically 4 hours, to read a table 30 times. If you run just one report at a time, it takes about 2 hours. So even with very basic elementary school math, you can figure out that 30 times 2 hours is going to be way more than 4 hours. So doing nothing will not work anymore. Yeah? And we didn't start out like this. We had nothing. It grew, so we had some time to figure out what I'm teaching you today. But it's here. So the tools that we have hardware, server storage. Yep. I mean, if you buy a tiny box or you get a tiny VM in the cloud, you can't deal with a large amount of data. The SQL Server version, standard, enterprise, BI edition. These slides are a little bit older, so that BI edition doesn't even exist anymore. So the good news is no longer there. You can have clever configuration, and you can clever query scheduling. Yeah? And we will go through all 4 of these areas. Hardware. I refer to it as the grade of steel. It's a measurement used in engineering. How much can I get out of my hardware? And we're not talking nuts and bolts here, but effectively it's the same. Yeah. So first of all, the CPU should normally not be the limit. Getting CPU is super easy, especially in the cloud where everything is centered around virtual CPUs. And normally to get more I/O, you have to get an insane amount of CPUs anyway. So CPU will not be the limit, but let's have a look what a modern CPU can do. Yeah. modern CPU, and the fun part is hasn't changed in about 10 years. The problem is they get a little bit faster, but the clock speed comes down every year, and they get more cores. And with a CPU, I mean a single core. Yeah, 500 megabytes per second per core is something that is reasonable. If you have super complex calculations or aggregations or something, no, that's slower. But when we're talking about the typical query that runs across a fact table, read these columns, group by some of them, aggregate some of the others, cross-reference with other tables, a few more, about roughly 500 megabytes per core per second. Yeah? So how many cores do we have in a commodity server? And you and me might massively disagree what's a commodity server, but servers you can buy, you can have today between 4 and 64 cores per CPU. 4 cores is available from Intel, 64 cores is available from AMD, and you can have pretty much any number in between, and you have to choose. Okay? And this is where we differ. Thing is, you can have 1 or 32 of these CPU, up to 32 of these CPUs. In a commodity server, you have either 1 or 2. Okay? I agree with that, but there are servers out there where you can have 32. Yeah? And they work just fine. Yeah, so that's somewhere between 4 and 869 cores. The reason is you can't have 64 cores in 32 sockets. You can only have 28 cores. Yes, yeah? And that means you can scan some.
Hello, Tom. Hello, Tom. Can you hear us? Hey guys, I give you access to unmute yourself. Can you guys hear Tom?
I can't. I don't hear you, Kate.
You can?
Nope.
No.
It seems like we lost him. I just pinged him. He was having internet issue. He just pinged me. He said his internet. Yeah, he just pinged me. So just Give him a second. He's joining again.
Thank you, Jed.
You're welcome.
Okay, let's try this again.
Yeah.
I'm so sorry. I have no idea. Normally my internet is pretty good. Why is this thing jumping over here every time I click on something? Okay, can you see my screen again?
Yeah. It's loading.
Yeah. Okay. So
I think we can see your screen now.
we went through the CPU. I hope that I was still visible, and then I will start on this slide again. So trying to understand how SQL Server scans data. SQL reads data page by page. All tables are broken down into individual pages. Each page is about 8 kilobyte size. Yeah? But SQL Server may do something which is called a read ahead. A read ahead is when SQL Server knows I have to read all the data in a table. I don't have to read it page by page. I can read a bunch of pages in one go. Yeah? And it can dynamically adjust the size of the read ahead. So it can decide to do 2 pages, 8 pages, all kinds of numbers. The maximum in standard edition is 128 pages. The maximum in enterprise edition is 512 pages. 512 pages is 4 megabytes in one go. Yeah. And reading 4 megabytes doesn't take much longer than actually reading just 8 kilobytes. The work with reading data from a drive or from the network is not in actually transferring the data. That is usually not the limit. The limit is getting there, asking for it, the device finding it, and then returning it. That takes much longer than actually transferring it. Yeah. So the time it takes to get the data is called latency, and the amount of data you can push through per second is called throughput. Throughput can be fixed. You need twice as much throughput, you put twice as much storage devices behind the problem. The problem is if your latency doesn't go down, putting 2 devices, 10 devices there doesn't change the latency of each individual one. Yep. So reading bigger chunks at once massively speeds up I/O between disks and things on all devices. Yeah. So that's 1 megabyte in standard edition, 4 megabytes in enterprise edition. Yeah. And the goal is to read ahead as much as possible. So how can we help SQL Server to achieve that? Yeah. A read ahead happens if the next data needed is in contiguous pages on the disk. So if the next 3 pages that SQL Server needs to read are next to each other, it can read them in one go. If they're spread across the file in all kinds of locations, it cannot. So this is referred to as fragmentation. Yeah? And there's plenty of talks about how to do index rebuilds and all that. The problem is index rebuilds and all that is not enough. Yeah. So if this is a data file and you have your individual little pages here and you have just one table and that's all that's in that database and you grow it, it will allocate one page after the other and they will all be contiguous. Yeah, because that's just how SQL Server works. But the problem is once you have 2 tables or more and they grow at the same time, what happens is that the blue and the green table will allocate from the same stream inside that file, and the contiguous blocks are interrupted by each other. So when now SQL tries to read, it can only read this 1, 2, 3, 4, 5. Yeah. So to do the same thing that it could do in 1 IO, it now has to do 5 IOs in our example here. That's assuming this whole thing is less than 4 megabytes in size. Yeah. So another, and this is just for the understanding. Now we have to understand the concept of multiple data files. Yeah, we can add multiple files, and in large databases, this is not uncommon. Nobody wants a single database file that's a couple of terabytes in size. You want to have multiple. The problem is, what happens now is that the first page goes here, the second page goes into the second file, third, fourth, fifth, sixth, and so on. So what's happened is SQL is constantly jumping in between these. So if now you want to read the first 10 pages, it has to do 10 individual IOs because neither one of them is contiguous. There's always space in between. Yeah. And it gets even weirder when the files are not the same size, because then SQL allocates proportionally. So you have 2 here, 1 here, another 2 here, 1 here, and so on. Yeah. So multiple data files, and we have the problem that we can't get the pages next to each other. Yeah. SQL is not that horrible, because what SQL practically does is it always allocates one extent at a time, which is 8 pages. So you have page number 1 to 8 here, and then 9 to 16 here, and then 17 to 24 here, and so on. Yeah. So at least it can read 8 pages, but that's far below the possible 512 it can do. So how do we fix this? Yeah. So then if you then have the 2 files plus you interleave multiple tables, it gets really messy, as shown here. Yeah. So one thing you can do is you can have multiple file groups and then have one table in one file group and the other table in the other file group. That again gives you a nice contiguous thing. Problem is, if you have 100 tables, you would need 100 file groups to achieve that. So that's also not practical. Yeah. So what can we do? What can we do? So far, we only learned that we have problems and no solution really fits. So there's one magic trick that SQL Server has that I use in everything that is remotely a data warehouse. Data marts, data warehouses, anything that will have large table scans, I turn that option on. And I turn it on very early, right after I install SQL Server. And that's an option called -E. Yeah. I don't know what the E stands for. I know what it does. It can be your friend if you have large tables. It's not your friend if you have thousands of small tables. Yeah, then don't do it. But if you have large tables, that's a very good option. And I remind you, that's an instance level setting. So that means that it also applies to TempDB. And that's why sometimes you have to be careful. If you have mixed workloads that creates thousands of small tables, that might be a bad idea. But if you have your data warehouse, your data mart, that is what you should use. What does it do? Instead of allocating one extent at a time, so one extent is 8 pages, it allocates 64 extents at a time. Yeah, that means it allocates 4 megabytes in one go for every table when it reserves space. So tables, instead of growing 64 kilobytes at a time, they now grow in 4 megabytes at a time. And if we remember, what was 4 megabytes? 4 megabytes was the maximum read-ahead speed size we can have. So what happens now, if I create, again, I have my file and I have my 2 tables that grow at the same time. The first table, blue, allocates 4 megabytes, fills it up. Then the other one comes in, allocates 4 megabytes, slowly fills it up. This first one comes back, allocates another 4 megabytes, and you have the whole thing here. When you read it, it can read 4 megabytes at a time, couldn't read any more anyway, so we're in optimum configuration, and then it can read the next 4 megabytes in the next block. No difference between one table and 2 tables. If I would have 2 tables, it would have been this, and then this area, and then this would be the third read. Yeah, but other than that, The cost is every table is at least 4 megabytes in size. So if you have a couple of thousand small tables, you're wasting some space. Again, that includes the one in TempDB. So if we now revisit multiple data files, we have our two tables that grow at the same time across both tables. First one allocates in the first table, then one in the second, then one in the third. Same as before with just one table, with just one file. All the reads are perfectly aligned, maximum size you can do in one go. Yeah? If you look at this, if I read 8K pages one at a time, yeah, 8K, let's say, for easy math, it takes 10 milliseconds. Yeah. If I read 64K, let's say, again, for easy math, it would take 15 milliseconds. So for 8 times the amount, we have 1.5 times the work that we do. For the 4 megabytes, yeah, it will probably take 20 milliseconds to do so. Yeah. So for 64 times 8, for 512 times, we need about 2x the time to read it. So doing this helps a lot when getting data out of it. This assumes, of course, that your throughput is not the bottleneck now. But the latency, we took the latency problem out of it. Because instead of running 512 times 10 milliseconds, which is almost 5 seconds, we can still do it in 20 milliseconds from a latency perspective. So how can we now make sure that we have the throughput that we need? In storage technologies, there's 2 major categories. Now there's 3. We will touch on a third one very
Are you there, Thomas? Can you guys hear Thomas? It seems like we lost him again.
Hi, Gene. It looks like, yeah, we lost Tom again. Yep.
Right. Give me a second. Thank you so much. Sorry about that, guys. I'm trying to reach out to Tom. Just give us a second. I just texted him. He said he's gonna join us soon. Just give us a second.
Here I am. Can you hear me?
Yes, we can.
This was funny. I could still hear you guys. I could not asking me if I'm here, but apparently you could not hear me anymore. I have no idea what this is. I'm sorry. I think let's try to continue. Thing is, so when you have I/O devices connected and you have one file on one drive, that's your base speed. Thing is, when you put two files on the same drive, nothing changes. It's a pure myth of SQL Server that you need multiple files to have more I/Os. SQL Server can perfectly do thousands of I/Os against one file. Two files are just a convenience to manage things better. Yeah. If you have a RAID between multiple drives and you put a file on it, it depends on the implementation of your RAID. If you have the same basic speed as of a single drive, or if you have twice the speed, because a RAID can decide to offload the data and spread it across the two drives. If you have two drives and you put one file on each, you get 2x the speed. If you have three drives and you put three files, one on each, you get 3x and so on. Yeah. If you do a RAID 5, so you combine these drives, or a RAID 6 something, you will get somewhere between more speed or less speed. In this case, it's when you have 3 drives in a RAID 5, you can get 2x speed, or you can get half the speed. That is the case if one of the drive fails, then your performance tanks. Or if you have the same RAID 5, but in this case with 5 drives, in the perfect scenario, you get 4 times the performance of a single drive. But if one of them fails, you are down to the quarter of one drive for your performance. Yeah? So RAIDs have a downtime and have a problem, a downside, that if they are not running perfectly, their performance really goes down. And this is why there is so many people saying you should not use RAID 5 for databases, only RAID 1 or 1.0. So that's what it is. If you do the same thing on a SAN, same thing. If you have one SAN volume and it's underneath on its own drive, you get 1 time the speed. Same with 2 files, so no difference there. But if you put 2 files on 2 drives and on the underlying SAN, they are not separated on physical different drives, you still only get 1x the speed. If they are underneath one drive. If they're underneath actually 2 drives, then you get 2x. Yeah? The problem is that in most implementations, this detail is hidden from you and you don't know it. Yeah? So in a network attached storage, you have to ensure that there's enough paths there. And on most SAN arrays, the paths are the limiting factor. I've rarely seen an implementation where they have enough bandwidth to the storage array, because storage arrays were not designed to be fast. They were designed to make management easy. So performance is actually insanely expensive on it. So what I've seen a lot is if you have a SAN storage, disable the read cache. Read cache, SQL will not read a page twice as long as it's in the buffer pool. The buffer pool of SQL Server is much bigger than any read cache in any drive storage array I've ever seen. To recap this, I made a little diagram. This is the path to the storage. You have your computer, then you have your HBA in there. From there, it has to pick one of the 2 switches it's connected. The switch then has to figure out which path to take to get to the fiber channel port on the other side of the storage array. The storage array will do a cache lookup, will not find anything there because SQL Server is clever and doesn't ask for something it already read before. It will then hand it over to the controllers for the drives. They will locate the drive will read it, and then return the whole path. Just that it took me almost a minute to explain that shows how slow that is. When you have, on the other hand, direct-attached storage, you have your controller inside your computer. It figures out where the data is and returns it to you. Yeah, much faster. Here we're talking 0.5 to sometimes 20 milliseconds. Here we're talking 0.25 milliseconds on average. Yeah, so that is much better. Yes. The newest technology, and with new I mean the last 3 to 4 years, is called NVMe IBM5. Yeah, these are direct attached drives that don't use a controller anymore. They are connected directly to the CPUs. So when you ask for the data, it's there. We're not talking a latency of 0.02 milliseconds. Yeah, several times faster than direct attached, infinite times faster. We're talking 100 to 1,000 times faster than SAN storage from a latency perspective. Yeah, and if this is not fast enough, you can use persistent memory. Problem with persistent memory, there's a size limit, how much you can have. And that makes it usually not helpful for large tables, but it can make it super helpful for things like lookup tables or so. So where are the I/O bottlenecks? Rotating disks, if you're still using them, stop. No, the time is over. There's 0.1 gigabytes per second, best case. Yeah? Disk interfaces that are on so-called SSDs, first generation, 1 gigabyte per second tops. Yeah, if you're super lucky, usually it's half of that. RAID controllers, they usually have a limit of 8 gigabytes per second. I've seen newer models that goes to 15, but not above that. So again, while this was a good option 10 years ago, it's no longer. Yeah, fiber channel, that's what you use to connect to your SAN. They are on average 2 gigabytes per second these days. Again, yeah, it's fast, but it's not really fast. Host bus adapters are basically the same as fiber channel, just for attaching drives directly. You can get up to 4 gigabytes per second there. And then when you connect PCI Express buses directly to NVMe drives, you can get up to 32 gigabytes per second. The product is called Honey Badger and works just fine. Practically, it turns out to be about 29 gigabytes per second with kind of driver overhead, but in theory, it's 32 gigs. And then you also have Ethernet when you use regular network, depending on your speed. When you have 100 gigabit per second network, you get about 10 gigabytes per second. Again, network compared to direct attached is no comparison. If you aggregate the largest computer you can buy right now for SQL Server, you have 64 PCI Express buses for storage. That gives you about almost a terabyte per second from an I/O perspective. And this is compared to your fiber channel, again, SAN storage versus direct attached. You can have multiple of these 2 gigabytes per second thingies, but you need a lot of them to get to 960 gigabytes per second. So this was hardware. Usually in the cloud, you have no control over of the hardware, but you know what to look for when you select virtual instances. Schema and table index options. Partitioning. Partitioning is great in Oracle. It doesn't do anything for performance in SQL Server. The only thing partitioning can do is a query can do partition elimination, but every index does that with one more layer in the index tree. So not really massive gain there. Partitioning, but is necessary in large tables so you can maintain them. Yeah, because if you ever tried on a 10 petabyte table to rebuild an index in one go, it's not happening. But if you partition the table in nice little terabyte chunks or so, you can easily rebuild your indexes. But you might need partitioning to spread data across multiple file groups if for any reason you want like yearly file groups or so that at some point later in time you can just drop the file group from the database and don't have to deal with deletes. There are features in SQL Server since 2008 R2 that are row and page compression. If in your system storage is the bottleneck, turning that on will help you. If storage is not your bottleneck, it will save you money on the storage, but not gain performance. That's the simple formula. Row compression is just doing very lightweight and basically removing all unnecessary things. So, for example, if you have a column that is an integer, but you're only storing values between 1 and 10 in that column, SQL will figure that out and only use 1 byte instead of 4 bytes to store that integer. Yeah? And remember, 1 byte less on a billion rows is a gigabyte saved. Yeah? 1 byte less on a trillion rows is a terabyte saved. So if you can save 100 bytes in 1 row, you might save 100 terabytes in size. Yeah? So do not underestimate that. Page compression has some overhead, but can save you a lot if you have repeating patterns within close by record. Yeah, so that's good there. Keep in mind, newly inserted data is not compressed. When you insert data, page compression does not kick in. You have to rebuild the table or the indexes to have that happening. Never compress lookup data. If you look up data every time, it has to uncompress it every time you need a row of it, it will slow you down. Yeah, but the large fact tables, it might make sense.
Tom, I don't know if you can hear us, but you froze up again, buddy.
I think you are right. I'm not able to hear him. Let me quickly reach out to him. Give me a second. Okay, he is joining us back. Just give us a second. Sorry about that, guys.
Come on, Gene. You should be able to sing and entertain us during this downtime, Gene.
Come on, John. How are you doing? I did not see you on the call. How's everything?
I agree with John. Come on, Gene.
Oh my God. So how are you doing, guys? So just give us a second. He's reconnecting now.
Okay, one more try. We're almost at the end, so we should make it to the end with this round.
Well, thanks for sticking in there, man. I appreciate it.
I have no idea what's going on. Normally my internet is pretty stable. They must be doing something because that can't be on my end 4 times in 1 hour. Yeah, I've seen routers fail, but not that often. Anyway, let's go quickly back to the thing is, yeah. So the first awesome tool I'm gonna show you is called merry-go-round piggyback scan, and I bet nobody has heard of this before, but guess what? It's in SQL Server since 2008. And it's documented in Book Online, but it is not linked from anywhere. So if you search for it, you can't find it. Best hidden secret in SQL Server, but you will learn it now. So what happens is we have one of our files and we have one query that needs to read the whole file. So what happens is that query starts reading at the beginning and reads through the whole file. Keeps going. What happens if now I start a similar query or the identical query again? Basically a query that needs to scan the same table. Yeah? So query 1 needs to do a table scan. Query 2 needs to scan the same table. If we would not have merry-go-round piggyback scan, query 2 would start at the beginning and do exactly the same as query 1. And with bad luck, it would be sitting here. And that data just fell out of the buffer pool and it had to read it again and do the same thing. But we are lucky and SQL Server has that concept of piggyback scan. So what happens is that query 2 doesn't start at the beginning of the file. Query 2 starts at the same place where query 1 is right now and piggybacks on that query. So they read the data once, process it both, and then move on. So together they reach the end of the file. Query 1 now is completed and will finish and return the result to the customer. And then query 2 will wrap around, that's the merry-go-round part, and finish whatever it needs to scan to come back to where it started. Yeah. So first of all, it does the piggyback, and then it does the merry-go-round and start from the beginning. So instead of reading the whole thing twice, we read that part here twice, but the majority part here, we only read once. Yeah. And the nice thing is you can have many, many, many of them. Yeah. Practically, you can have one per core if you restrict your queries to one core, yeah, to make that efficient. Yeah. So that's a lot in these days. Yeah. So problem with that feature is it's enterprise edition only. But on the other hand, if you have multiple terabytes of data, you're probably going to run enterprise edition because standard edition will already not have enough memory and not have enough CPU support to run that. It's automatically invoked. There's no hints. There's no nothing that you have to do. Is all it needs to exist is two queries scanning the same table. They will share the work. Yeah? Or 3, 4, 5, how many. Yeah? And with some planning, you have much better results. The basic instinct of every DBA would be to schedule the reports apart. But knowing that that feature exists, having like 32, or if you need 30 reports, having 30 jobs scheduled to start within the same second and all scan the same data is going to be much, much faster overall than each individual. What happens is, of course, when you run 30 at the same time, they run slower. So when you remember at the beginning, we had the case that we have 30 reports that each need 2 hours. From what we practically saw is that if we run them all at the same time, each one needs 4 hours. But the difference is, instead of 60 hours, we completed the whole thing in 4 hours, which was enough time that we needed. Yeah. And adding more CPUs to the machine actually made it faster. But we didn't have to increase I/O or anything else because this was shared. So instead of reading the whole data 30 times, that feature makes sure it's read once. This is a case where we had 30, but in your case, it might be 2 or 3 reports that need the same thing. Still, you will see a massive gain. Problem is, enterprise only. Yeah? And there's nothing you can do. There is, if you look in I/O stats, it will tell you in I/O stats that it did a piggyback scan. That's the only place you can detect that it happened. And coming to the last magic trick that was introduced in 2014, 2016, but it became actually useful in when it became a clustered column store index. And I have a whole separate talk on this thing. The summary is it has awesome compression ratios. The best one I've seen so far is 168 bytes per row became 3.5 bytes on average. Yeah, so 3 trillion rows were stored in 12 terabytes of data. This was more than a petabyte by itself, and it compressed it down to 12 terabytes. You have to help it by sort the data so it can perfectly thing is. What column store does is instead of reading the whole row, it only fetches the referenced columns. So that is an awesome feature. It does partition elimination. So if you partition your clustered column store, it will actually only look at partitions that are affected by the query. It does row group elimination. What it does is it stores about 1 million records at a time. And it can figure out if any one of the 1 million records will be needed in that query. And if not, it just ignores 1 million rows at a time. So that is a massive speed up. It can push down filters, meaning the filtering is not done by SQL Server. The filtering is done in the storage engine, not by the query processor. Again, a massive performance thing is. And aggregate push down means group bys can also be done in the storage layer. So instead of returning the data, then calculating the aggregate, it just gets the aggregate back from the storage layer. And the last one is batch mode. Batch mode uses new features of CPUs. Modern CPUs, instead of just doing 32-bit or 64-bit operations at a time, can do 256 or 512-bit operations in one go. And batch mode basically does that by putting the data in memory in a way where one instruction can work on up to 8 like floating point numbers in one go. Yeah. So all these things are in column store, which would make which would be an alternative. So these days, column store or piggyback scan things. The optimization for 512 kilobyte for 4 megabytes extent size, I would do all the time because it helps both column store and piggyback scan. It helps things. If I use these days a regular table and try to utilize the piggyback scan, or if I use a column store index, depends massively on the query. Yeah. If the query can use either one of these efficiently, column store will be faster. If not, the row store will be faster. Sometimes the clustered column store comes in because I need the compression. Yeah. Because once you deal with petabytes of data, not compressing it is almost a crime. Yeah. So that's it. You can email me questions if you don't want to ask them now. Other than that, I open it up for questions. And I apologize one more time for my crappy internet today, but it is what it is.
You don't have to, Tom. So we can understand. And thank you, everyone, for being here. And by the way, Thomas, this is a great session. I really love it. If you guys have any question, feel free to go ahead and ask.
Hey Tom, Ashok here. One question is, do you recommend to enable hyperthreading for SQL Server at the OS level?
In a data warehouse, yes, hyperthreading makes sense because it's the same as with storage. Hyperthreading increases the throughput, but at the same time, it increases latency. Yeah. So in an OLTP system, no, don't enable hyperthreading. In a data warehouse setting, yes, hyperthreading makes sense.
Okay, thank you.
Yeah.
Quick question, Tom, about that merry-go-round piggyback scan.
Sure.
You don't have to do anything to invoke it. How do you know it's being used, or how do you force it to be invoked?
You can't force it to be invoked, so that's the bad news. The only way you can see if it happened or not is if you turn I/O statistics on, and then you get how many logical reads, how many physical reads, and if you had a piggyback scan, it will say that in the text message there. That's the only way you can see it. As I said, this is the most hidden feature in SQL Server. It's there, but it almost as if Microsoft doesn't want you to use it, but it's there. So it's set I/O statistics on, run a bunch of queries scanning the same table at the same time on Enterprise Edition, and
so it's not like it can configure your reports then to use it every time. It's whether SQL Server optimizes it to use it then.
It seems like we lost him again. Can you hear him talking? We probably lost Thomas.
Gene, do you know if he's trying to come back or is he finally given up?
No, he just told me he is trying to reconnect again.
Okay, thank you.
You're welcome.
Have a good day, guys. Thank you.
You're welcome. I think he is reconnecting, guys. If you guys have any question, you wanna stay, that's fine. I'll be patient with you.
Hello, I'm back. So the last question I got is, how do you get SQL Server to do that piggyback scan? So what we did, instead of scheduling one report after the other, which is the natural thing you would do, we made sure that all the reports that basically scanned the same tables, we started at the same time. And so we had 6 for this table, we started these 6 at the same time. And once they were done, we started the next 10 tables that were doing the next 10 reports that were using the other big table. Yeah. So that's the trick. You have to understand what your reports are doing, and then run the ones that access the same tables at the same time. Yeah, that's how you get that done. That's his answer.
I think he left, but we do have tons of other people still on the call. Do you guys have any questions?
I have lots of questions from my internet provider.
I don't have any questions, Tom, because you did a good job, man. Thank you very much. I really appreciate it.
Sorry, yeah. Sorry again for whatever happened there.
Yes, to be honest with you, carry on.
Yeah.
All right, I'm going to bail. Thank you, Tom.
Yeah, thank you.
Okay, that was an amazing presentation. Thank you so much, everyone, for attending our webinar. Feel free to follow us and share this meetup. This session is being recorded. I will keep you posted when the recorded video is available. Thomas, one more time, thank you so much for your session. That was a very great session, and I learned so much from it.
Thank you.
Bye, everyone. Hope to have you next year, Thomas.
Sure. Yeah.
Thank
With
you.
better internet, I swear.
That's okay. We cannot control that.
I will, because